Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss model fit indices of the measurement model. We have already talked about the 6 stages of structural equation modeling. In stage 1 to stage 4, we are assessing the reliability and validity of the measurement model. Once the reliability and validity of the measurement model is established, the same model is converted into the structural model, where we are having the regression paths. Now, what is this model fit? Let's try to understand. Model fit in structural equation modeling refers to the degree to which the hypothesized model adequately represents the patterns and relationships observed in the data. It assesses how well the model fits the observed data and provides an indication of whether the model is a good representation of the underlying structure being studied. Model fit is important in SAM because it determines the validity and reliability of the model. A well-fitting model suggests that the specified relationships between the variables are supported by the data, indicating that the model accurately represents the underlying theoretical constructs. The first thing which we have to do is setting the metric. What is this concept? Let's try to understand. Whenever we draw a model in the canvas, the oval represents the construct and the rectangle represents the item. In SPSS Amos, automatically one will be denoted on any one of the paths. It will be done automatically. Now, what is this concept of one? Let's try to understand. Assigning a value of 1 to one of the indicators in structural equation modeling typically implies fixing the scale or metric of that particular indicator. By setting a value of 1 for an indicator, you are establishing it as a reference point or a baseline for comparison with other indicators or latent variables in the model. This can be useful when you want to examine the relative strength or magnitude of the relationship between the latent variables and their indicator. For example, let's say we are having a latent variable called the customer satisfaction, which is represented by this circle. This customer satisfaction is measured with items CS1, CS2, CS3, and CS4, which is denoted by these rectangles. Now, if we set the metric of CS1, let's say this is CS1 as 1, then CS1 becomes a benchmark for CS2, CS3, and CS4. All our interpretation will be with the reference to CS1 as 1. Model evolution indices, also known as a model fit indices or the goodness of fit indices, are the statistical measures used to assess the quality of statistical models such as structural equation models, confirmatory factor analysis, or the regression models. There are three types of model fit indices: absolute fit indices, incremental fit indices, and parsimony fit indices. Absolute fit indices provide information about how well the model fits the observed data without comparing it to alternative models or the null models. Incremental fit indices are statistical measures used to assess the improvement in model fit when comparing the hypothesized model with more restrictive or baseline models. This indices helps researchers evaluate the added value of including specific parts or constructs in the model. Incremental fit indices provide information about whether the inclusion of additional variables or paths significantly improves the fit of the model or not. Parsimonious fit indices, also known as a model complexity adjusted fit indices, are statistical measures used to assess the goodness of fit of a model while considering its complexity or the number of parameters estimated. This indices aim to strike a balance between the model fit and the model simplicity, favoring models that provide a good fit while using a minimal number of parameters. The fit index, we are having three: absolute, relative, also known as the incremental, and the parsimonious. In absolute, we are having again two: badness of fit, that is chi-square test, SRMR, RMSR, RMSE. What these terms are, we will see in the next slide. And the goodness of fit is denoted by GFI and AGFI. Relative incremental, we are having indices such as NFI, TLI, IFI, RNI, BFI. In parsimonious, we are having PGFI, PNFI, and TLI. In my previous video, we had discussed that in validity testing, we are testing the construct validity, which is again divided into the convergent validity and the discriminant validity. In conversion validity, the composite ratio should be greater than 0.7, AVE should be greater than 0.5, composite ratio should be greater than AVE. In discriminant validity, we are talking about AVE, that is average variance extracted, should be greater than maximum shared variance, and AVE, average variance extracted, should be greater than average shared variance. This we have already discussed. In this video, we are going to talk about the model fit indices, in which we are having chi-square statistics, goodness of fit indicator, badness of fit. So let's see what these concepts are. Now each indices is having a threshold limit. We'll start with the first one, the model chi-square. In this case, it is necessary that the p-value should be more than 0.05. When we take the ratio of chi-square with the degree of freedom, its value should be, the ideal value should be less than 2. But researchers tolerate even the value up to 5. RMSEA, which is root mean square error of approximation, its value should be less than 0.08. It can fluctuate, and we can tolerate up to 0.10 also. GFI, goodness of fit statistics, its value should be greater than 0.90 or 0.95. AGFI, adjusted goodness of fit statistics, its value should be more than 0.80. RMR, root mean square residual, no thresholds. SRMR, that is standardized root mean square value, its value should be less than 0.05. So these are all absolute fit indices. Incremental fit indices, we are having normed fit index, its value should be greater than 0.90. NNFI, non-normed fit index, its value should be greater than 0.80. CFI, the comparative fit index, its value should be greater than or equal to 0.90. We are having Tucker-Lewis index, its value should also be greater than 0.90. In parsimony fit indices, we are having PGFI, that is parsimony goodness of fit index, its value should be greater than 0.90. PNFI, parsimonious normed fit index, its value should be greater than 0.90. Then we are having chi-square statistics. The chi-square test assesses the discrepancy between the observed data and the model implied covariance matrix. A non-significant chi-square p-value suggests a good fit. Listen carefully, a non-significant, indicating a non-significant chi-square p-value means the p-value greater than 0.05, indicating that the model does not significantly deviate from the observed data. It is necessary that the p-value should be greater than 0.05. And C minimum divided by the degree of freedom. Basically, C minimum is a chi-square, should be less than 3. In my previous slide, it was 2, but we can tolerate up to 5. Some researchers even consider the value of C, this is C minimum only, divided by degree of freedom, up to 5 tolerable. However, the chi-square test is sensitive to the sample size and may be significant for trivial departures from perfect fit in large samples. Chi-square is a biased statistics. Practically, the chi-square test of a model fit is strongly influenced by a sample size. That is, statistical power increases as sample size increases. Smaller differences are easier to detect with large samples, and larger differences can be missed in smaller samples. As the chi-square statistics is biased, academicians have developed other types of statistics such as goodness of fit and the badness of fit. Now, let us try to understand the same indices in Amos. So for this, we will go in the environment of the Amos. I already explained to you that how to draw this measurement model. Kindly refer my previous video. To understand the flow of this lecture series, I will request all of you to refer all my previous videos. Now click here. It is necessary that in output, some ticks should be done. Standardized estimates, squared multiple correlations. You can uncheck this and make sure the correlation of estimates are checked. What all these things are, first let me generate that output so that I can explain it later on. Now click on this. There are some you can say some interfaces which you will have to understand. The first is this one. It is necessary that you get this message in this box that the minimum was achieved. It means that your model has run successfully. Now there is an down arrow and there is an up arrow. Down arrow, if you want to edit something, you press the down arrow, and up arrow, when you activate the up arrow, it will show you all the measures related to this model. So let's press the up arrow. You can see the measures have been generated. Okay. Now unstandardized estimates and standardized estimates. See this unstandardized estimates, just click on it and standardized estimates. Now let me click again here. When you click on standardized estimates, you get these figures. Make sure that standardized estimates are on. Yes. So when you click on standardized estimates, you get this figure 0.58, 0.88, 0.66, 0.84. When you click on squared multiple correlations, you get 0.34, 0.78, 0.43, 0.70. Now, what is the relationship between this figure and this figure? If you recall my previous videos, 0.58, if you take the square of it, you will get 0.34. If you take 0.88 square, you will get 0.78. Basically, this is the variance explained by OC1. The remaining part, if you take the 1 minus 0.34, is the error term, E4. What are the correlation of estimates? This is the correlation between two constructs. You can see here. So let's try to understand this. Loyalty is captured with the help of four statements: S1, S2, S3, S4. These are the error terms which are E1, E2, E3, E4. The factor loading is beta, which we have already discussed, which is a standardized estimates. If I take the square of it, I'll get the squared correlation, which is the explained variance. If I take the difference of it, I'll get lambda, that is 1 minus beta square, which is an unexplained variance. So my average variance extracted is sigma beta square. That is the variance explained by S1, S2, S3, S4. If I take its average, I will get AVA. So I will consider beta square here. Now comes the composite ratio, which is so CR is a composite reliability where we take sigma beta, this beta, not this beta square, this beta, sigma beta square plus sigma beta plus sigma lambda. So lambda value is taken from here. So if I substitute this lambda, I will get composite reliability is equal to sigma beta square upon sigma beta square plus sigma of 1 minus beta square. Let's go back in the Amos again. Now, when you activate the unstandardized estimate, you will get the mean of the error as 0, and this is its variance. You can see here. So the model runs in such a way that the error is set to 0 and variance is 4.19. So these are unique variables. That is, the error terms are unique variables indicated by E in the model. Now, when your unstandardized estimate is on, the measure, that is the number which you get here, it is a covariance between the two constructs. When you click here and activate the standardized estimate, this is a correlationship between the two constructs. I repeat, in unstandardized estimates, this is covariance, and in standardized estimates, this is a correlationship between the two constructs. If the correlationship is high, let's say this one here, the correlationship is high. 0.56, it's not so high, but if it is, let's say 0.78, 0.78 or 0.80, there is a scope for a researcher to convert this into the higher order models. Now click on view text and you click on the model fit. So first we will understand what is the concept of default model, saturated model, and the independence model. The saturated model is a most complex model in which every possible relationship between the variables in the model is estimated. You can see here, all these are the constructs. All possible relationships are considered. The default model is a specific model that is pre-specified by the researcher based on theoretical or empirical considerations. It represents a particular hypothesis or theory about the relationship between the variables. You can see here, some arrows are not there. The independence model is the most basic and restrictive model where there are no relationships or association among variables. It assumes that all variables in the model are statistically independent and unrelated. So let's go here. So the saturated model gives the best model. Independence model gives the worst model. It is just like your blood report, where uh, your blood report fluctuates between the range specified, that is high and low. So for a researcher, he or she has to consider the default model. Its value will be definitely in between the saturated model and the independence model. Now we will go in the notes for the model. So the number of distinct sample moments is 230. Number of distinct parameters to be estimated is 70. The degree of freedom is 160. Kindly recall the video of degree of freedom in which I have discussed this concept. Basically, this is known. 230 is known, 70 is unknown, that is to be determined, and the difference is 160. So we are having positive degree of freedom, which means that the model will definitely run successfully. The chi-square value is 214.770. The degree of freedom is 160 and the probability level is 0.003. Now let's go in the model fit and click here. You see this value 214.770. This value is same as the chi-square value. Now when you will divide C minimum by the degree of freedom, you will get this 1.342. This is what was specified in the thresholds. This one. Its value should be less than 2. This one. Its value should be less than 2. But researchers tolerate the value up to 5 also. Let's go ahead and try to understand the output more. It's also known as a minimum discrepancy. Now comes the normed fit index, RFI, incremental fit index, Tukorlev index, CFI. All these values should be greater than 0.9. Now let's talk about the CFI. If this value touches 1, then it is problematic. In such case, a parameter needs to be removed or changed. Let's talk about the badness of it, RMSEA. This value 0.029, it should be less than 0.08, and yes, it is less than 0.08, which is quite good. Low 90, that is 90% confidence, and high 90% confidence, its value is even less than 0.08. The high 90 value is also less than 0.08, which is quite good. Now let's go in the estimates and try to understand this. You are having a 3 stars here, which means that these items are significantly contributing towards a construct. 3 stars means it is quite significant at 0.001. Now you can see this value 1.125, 1.67 and 0.8557. I told you that one of the item becomes a benchmark and others are compared with it. Now let's again go back in the canvas and activate the unstandardized estimates. So 1.13 is the highest here. Now if I make this 1 as a benchmark, definitely all other values will be lower than this. So we'll activate the edit button from here and I'll make this as 1 and I'll remove this one and I'll again run the model. Click on up arrow. You can see here all other values are less than 1. Similarly, 0.60 is the lowest. If I make this as 1, then all other values will be definitely more than 1. Let's try to do it. Press the down arrow, make it 1, remove this one from here, and again run it. Click on up arrow. You can see all other values are more than 1. Now let's go back in the output. Estimates. So all the items are having a positive relationships with the construct. This you can see by this 3 stars. It is quite significant. All of them are quite significant. Moreover, the standardized regression weights are are also displayed here. So the standardized regression weights provide the information about the relative strength and the direction of the relationships between the items and the construct. More positive, so the more you can say the explanatory power. Let's see the covariances. You can see here the covariances between the two construct. So the covariance represents the degree of linear association between the pairs of the construct. So you can see that organizational commitment and environmental perception co-vary with each other. So here covariances, correlations are also calculated. If here the correlations are more, let's say one of them is zero point 0.8 or more than 0.7, then we can go for the higher order models. Let's go for the squared multiple correlations. Basically, these are the R squares. These are generated here. This one. These are your R squares, 0.34, 0.78, 0.43, 0.70. These are the same figures which are generated here. Now, I can also generate the model fit indices with the help of plugin. So let me increase the size from here. Okay, you go in the plugin folders. The website is StatWiki Guessignation, and click on the plugin folders and click on the version, relevant version of Amos which you are having it. Click close, and from here select the model fit. Click on it. Then press the download. Now it will give you a warning. No need to worry. Press this up arrow and keep. Now you go in the downloads. Go in the downloads. Then you are having this modelfit.dll. Right click on it. Go in the properties and unblock it. Apply. Click OK. Now you will have to copy this. You will have to copy this model fit in the path which I am specifying. Go in C, users, admin, app data, local, Amos development, Amos 24, plugins, and paste this plugin here. As soon as you will paste this plugin here, this option will get activated. Model fit measures. This will get activated. Now simply you will have to press this. Press yes and done. You can see the model fit measures. It has given you the report card of your model. Quite good. So C minimum is there. It's the same thing. C minimum is the same thing which you got manually from here. Kindly check it. So click on view text. Let us go in the model fit. Let us check the numbers. Is it same 214.770? Yes, it is same. Degree of freedom, is it same? 160? Yes, it is same. C minimum by degree of freedom, it should be between 1 and 3. Excellent. CFI 0.986, quite good. And it also gives you the remark, congratulations, your model fit is excellent. So CFI greater than 0.95, RMSEA less than 0.06, and these are all your cutoff criteria. So this is all about model fit indices of measurement model. For more videos on SPSS Amos, kindly subscribe to my channel. You can see my playlist in which I already uploaded many videos on SPSS Amos. Don't forget to subscribe the channel and press the like button. You can also follow me on LinkedIn and Twitter.